So here's our second polynomial, x cubed minus 5x squared minus x plus 5. Now the first thing you might want to try is to pull out the GCF. But if you look at these four terms, x cubed, negative 5x squared, negative x and 5, they don't have anything in common except 1. Okay, the only number that goes into all the coefficients is 1. And it's useless to pull a 1 out. That's not going to change anything. So we're going to skip factoring out the GCF and then look over the procedure for the next method we should use. Because this is a 4-term polynomial, 1, 2, 3, 4, the factoring method that's suggested is factor by grouping. So we need to group two pairs in this polynomial and factor the GCF out of each pair so we can then factor out the overall GCF. So let's start by grouping this correctly. One important thing to remember when you're factor by grouping is that the negative sign here in the middle should stay attached to the x. So it needs to stay in the parentheses. And then you put a plus sign between your two groups. Right? Plus a negative x is the same thing as minus x. Okay, but the negative sign should get grouped with the second grouping here. So let's see if this grouping will work. For the first pair, x cubed minus 5x squared, the GCF is x squared. So let me pull that out to see what we're working with. We'll have an x squared out in front and then an x minus 5 left inside the parentheses. Now, in the second group, the only number that these two terms have in common is 1, or actually they also have a negative 1 in common. And if you compare this binomial factor here to this binomial factor here, if you want to get these to match, you're going to have to pull out a negative 1. This has a positive x, this has a negative x. So in order for the factor by grouping to succeed, you have to factor out a negative 1 from the second grouping, which means we're going to put a negative 1 outside of parentheses and then fill in what we would need to fill in to get back to minus x plus 5. So negative 1 times x will give you negative x, and negative 1 times negative 5 will give you positive 5. Okay, so by factoring out that negative 1, we effectively change the signs in the parentheses here. And now we have a matching overall GCF. Right? This x minus 5 and this x minus 5 can be pulled out front. So let's do that. That's our next step in factor by grouping. So we'll end up with a factor of x minus 5 multiplied by, well, there's an x squared left over from this first term, and a negative 1 left over from the second term here. All right, so we've factored our polynomial, but have we factored it completely? Well, let's think. Can we break down x minus 5? No, there's no GCF to pull out. It's got an exponent of 1. There's not much we can do with it. Can we break down x squared minus 1? Absolutely. This is a difference of squares, right? This is x squared minus 1 squared. Okay, so we can break down the x squared minus 1 further. Let me write the x minus 5 first. Now to break down x squared minus 1 squared, you do x minus 1, x plus 1. Now our polynomial is factored completely. There's no way you're going to break down x minus 5, x minus 1, or x plus 1. So there's our factored form for the polynomial x cubed minus 5x squared minus x plus 5. Okay, so here's the next polynomial we have to factor. 125m to the fourth minus 400m cubed n plus 195m squared n squared. So the first step when you're factoring any polynomial is to try to pull out the GCF. So we're going to have to analyze these coefficients and see if we have a factor in common. So let's factor them down quickly. So after breaking down the coefficients, we see that each number has a 5 in common and nothing more, since 195 only has a single 5 in it. So we can pull a 5 out in front. Also, every term has an m squared, right? Here's an m to the fourth, here's an m cubed, here's an m squared. So as far as the variables go, everything has an m squared. So we're going to pull out 5m squared as our GCF. And then inside the parentheses, we have to figure out what to put so that we would distribute back to this polynomial. So we know that to get 125 back, we're going to need a 25 here. 5 times 25 is 125. To get m to the fourth back, we're going to need an m squared here. Okay. Now, to get minus 400 back, we're going to need minus 80. Right? 5 times 80 gives us the 400. To get m cubed n, well, we already have m squared, so we need an m. That gives us m cubed, and then an n. And then finally, to get 195 m squared n squared, well, we have a 5 outside, so we need a 39. 5 times 39 is 195. And then the m squared is right here, so we need to tag an n squared on there. At this point, we've factored our polynomial, but we have not factored it completely, because we can break down the trinomial inside these parentheses more. Okay, so that's our next step. Remember, to factor trinomials, we use reverse foiling, and to keep track of our reverse foiling, we use a box diagram. Okay, so what I really need to figure out right now are the factors of this a coefficient and the factors of this c coefficient. I'm not going to worry about the variables till the end. So as far as factors of 25 go, we have 25 times 1, or 5 times 5. Factors of 39, we have 39 times 1, or 13 times 3. Now we need to make our box and figure out which combination of these factors will add up to the negative 80 in the middle. So let's experiment. So for our a factors, let's start with 5 and 5 since they're closest to one another. So I'll put a 5 and a 5 in the first column. That gives me my 25. Then I'll do 13 and 3 for my second column. 13 and 3. And then we'll check to see if it works. 5 times 3 gives me 15. And 5 times 13 gives me 65. These can combine to 80. 65 plus 15 is 80. Okay, so this could work. Now, if we need a negative 80 in the middle, like we have here, then the 65 is going to have to be negative, and the 15 is going to have to be negative. So those negative signs come back to our c factors. But that's okay, because negative 13 times negative 3 is still positive 39. So this box diagram gives us our factored form of this trinomial. Now you have to be a little careful here. Okay? Because we have an m squared out front, we're going to need m's attached to the 5's. 5m times 5m is 25m squared. Because we have an n squared on the back end, we need n's attached here. Negative 13n times Negative 3n gives you 39n squared. Now the middle will work out because 5m times negative 3n is negative 15mn, right? When you multiply these, your mn pops up. Same thing here. Okay, so everything FOILs out perfectly, which means the factored form of this trinomial, take the top row, 5m minus 13n, times the bottom row, 5m minus 3n. Okay, now this is not the factored form of our original polynomial because we had a GCF that we pulled out. So this guy's got to come down. So you should have a 5m squared, your GCF, multiplied on the outside here. So this is the final factored form. So here's our final polynomial that we have to factor. It's negative 3x to the fifth plus 12x to the fourth minus 51x cubed. Right? As always, the first thing you want to try is to pull out a GCF. So let's break down the coefficients and see if they have anything in common. So 3 can't be broken down, it's prime, but 12 has a 3 in it, and 51 has a 3 in it. So altogether, for our coefficients, the GCF is going to have to contain a 3. Now, as far as our variables go, x to the fifth, x to the fourth, x cubed, you're going to have an x cubed in the GCF. Okay, so when I factor this, I'm going to write 3x cubed outside parentheses. Almost. Okay, the other thing I want to account for is this negative sign in front of my x to the fifth. Okay, in general, if you have a negative coefficient in front of your highest exponent term, the variable with the highest exponent, you want to pull that negative out in front with your GCF. Okay, so instead of pulling out 3x cubed, I'm going to pull out negative 3x cubed to help me get rid of this negative in front. Okay. What that's going to do, it's going to have the effect of changing all the signs inside the parentheses here. Right, so when we go to fill in our empty parentheses, we need to think, okay, what do I have to multiply by to get negative 3x to the fifth back? Well, I already have a negative 3. This x cubed would have to get multiplied by x squared to give me x to the fifth altogether. And we move on. What do I have to multiply negative 3x cubed by to get positive 12x to the fourth? Well, a negative times a negative is a positive, so I'm going to need a minus here. Minus 4 will give me positive 12 when I distribute again. And then I have x cubed, which means I need another x. X cubed times x is x to the fourth. And then finally, to get the minus 51x cubed back, I need a positive 17. So at this point, we've factored our trinomial because we wrote it as a product, but have we factored it completely? In other words, can we break down this trinomial inside the parentheses? Can we break down x squared minus 4x plus 17 by reverse foiling? Well, the only way you can really figure that out is by trying. Okay, so you're going to have to take factors of a, right, factors of this 1 in front of the x squared. Right, the only factors are 1 and 1. And then take factors of 17, which is your c value. 17's prime, so the only factors there are 1 times 17. And then you use your box and see if you can combine these in any way so that the diagonals add up to negative 4. So hopefully you're seeing right now that there's not much choice here. All you have are 1 and 1 for your factors on the A, so you have to put 1 and 1. And all you have are 1 and 17 for your factors of C, so you have to put 1 and 17. And then the diagonals are going to be 17 and 1. There's no way that 17 and 1 are going to combine to 4. Okay, so this box will not work. And if you flip, it's going to give you the same thing. Okay? So there is no possible combination of these factors that's going to allow you to reverse FOIL this trinomial. Which means actually after we've factored out the GCF, we are all done. The polynomial is completely factored since the trinomial cannot be broken down anymore. Right, the guy inside the parentheses will not reverse FOIL, so this is our final answer.